Hi guys, this is video 4 for the lesson on equations of lines and planes. We're asked inside this question to write a standard form equation of the line through the point 5, 1 with remote vector -1, -2. Now to begin with, I don't have to do this, what I'm about to do, but I want to do it anyway. I'm going to start with, we can start with point normal form. N dot x minus p equals 0. So -1, -2 dot x, y minus five, 1 equals 0. I'm going to distribute that dot product. So -1, -2 dot x, y minus -1, -2 dot 5, 1 equals 0. And then complete those two dot products. I have -1 times x, so -x, plus -2 times y, so -2y, minus -1 times 5, plus -2 times 1, so -2, equals 0. So -x minus 2y minus -7 is equal to 0. So -x minus 2y plus 7 equals 0. Negative and negative is positive. This isn't yet in standard form. It has to be. It's almost in standard form. Almost there. Need ax plus by equals c. So I need to subtract 7 from both sides. -x minus 2y equals -7. Or multiply both sides by -1. So this is optional. We will not make you do this. That's something you could optionally do. And get x plus 2y equals 7 as an equivalent formulation of that line. But that was a lot of work. What we could have done is we just could have said the answer is -x minus 2y plus n dot p. So again, -x minus 2y equals n dot p. N dot p, -5 minus 2, -7. So we get that answer in one line, but this is the explanation for why that formula works. Okay, next one, write a point normal form equation for the line given in standard form. Point normal form, what do we need? We need a point, we need p and n. Now from the standard form, we can directly tell what n is. N is equal to the coefficient in front of x, comma, the coefficient in front of y, 2, -1. We have to get the point P. This is any point on the line. So you can either pick a number you want for x and solve for y, or pick a number that you want for y and solve for x. I'm going to pick a number for x because that's what we usually do. So I'm going to choose x equals, I feel like choosing 10. You can choose 0. Choose x equals 1, x is 2, x is 3, x is 0, etc. Anything you want will give you a point on that line. I just felt like 10. So 20 minus y is equal to 6. Minus y is equal to 6 minus 20, subtracting 20 from both sides. So minus y is equal to minus 14. And that means y is equal to 14. So P is, we have point P, which is 10, 14. Now we can write our equation. Thus, n dot x minus p equals 0 is given by the normal vector that we read off, 2 comma negative 1 dot x minus p, the point vector p, 10 comma 14 equals 0. Common error is to forget the equals 0 for a point normal form. It is absolutely necessary. If you hide that equals 0, you just have a dot product between two things with no restriction, with no requirement. Equals 0 is what imposes the requirement on the coordinates x and y. It's only a point x and y are only a point on the line if this dot product is actually equal to 0. So that's what creates the stream or string or set of all the xy coordinates that are on the line. It's that requirement, it's that condition, the equal 0 of that dot product. So it's crucial, it's an important part of the definition. Okay, next one, write a standard form equation of the line given by this thing in point parallel form. So for a standard form equation, we need a normal vector, n, and a point P. Given point P 0, 1 from the point parallel form, and V equals 2, 3 from point parallel. So we're given a point parallel form, we can extract a point and a direction vector. Now we need to turn that direction vector into a normal vector. N is equal to, so I'm going to swap the components, 3, 2, and put a negative sign in front of one of them. So negative 3, positive 2, or positive 3, negative 2, it doesn't matter. Now I have what I need. So this says that we'll have negative 3 plus 2y equals c. Now how do we get c? C is equal to n dot p. Shortcut. I'm going to use it. We already went through the derivation twice. So normal vector n, negative 3, 2 dot p, 0, 1. We get 0 plus 2 equals 2. So that we'll put in there for c. Negative 3x plus 2y equals 2. That's our answer. It's worth doing a quick check. Does this contain the point 0, 1? So if x is 0, what is y equal to? So I got negative 3 times 0 plus 2y is equal to 2. So 2y is equal to 2, y is equal to 1. It recovered the point 0, 1. It's just a quick check. Quick check that all the arithmetic was done correctly. All right, now we have a combo problem. We're asked to do a whole bunch of different stuff, given two inputs. We're given a point P and a point Q, and from that we want to construct the 2 point, the point parallel, the normal, the standard, and the parametric. So how many is that? 1, 2, 3, 4, 5. I'm counting it. 1, 2, 3, 4, 5. 5 different answers. We're going to have 5 answers to this question. I'm going to make boxes starting with the 2 point because it's the easiest. So it doesn't need a lot of space. And then point parallel is the next easiest. that in this box. Maybe you need a little more space than that. You'll see in a moment why I'm putting them in boxes. And then we'll have point normal. And parametric. And then standard. Okay. So for 2-point, super simple. It's x of t equals 1 minus t times one of the points, so 1 comma 5, plus t times the second point, 6 comma 10. That's it. Point parallel, we need to construct the direction vector v. So q minus p. So 6 minus 1, 5. 10 minus 5, 5. So x of t is equal to p plus t times v. So 1 comma 5 plus t times 5 comma 5. That's our answer. Now it's easy to go from point parallel to parametric, so I'll do that next. By just splitting up the components. The x component is equal to 1 plus 5 times t. The y component is equal to 5 plus 5 times t. We can go from the point parallel with a little bit more work to the point normal. We found v equals 5 comma 5. So our normal vector n is negative 5 comma 5. I flip the components and put a negative sign in front of one of them. That will result in a vector that's orthogonal to the direction vector. Now I have all the ingredients I need. I have the point, I have n, so n dot x minus p equals 0 is negative 5 comma 5 dot x minus the point p 1 comma 5 equals 0. And then it's straightforward to go from the point normal to the standard. So negative 5x plus 5y equals n dot p. Minus 5x plus 5y is equal to put in the vectors. N we just found was negative 5 comma 5 dot p is 1 comma 5 equals negative 5 plus 25 is equal to 20. Wish I had another line under this. I have many regrets from drawing the boxes the way I drew them, but that's okay. Uh-oh. Uh-oh, don't do that. So we'll just continue this up here. So we have negative 5x plus 5y equals 20. So that's the sequence. If you're going to construct point, normal, standard, or parametric, given 2 points, I'd start by constructing the point parallel, then go to point normal, going from the direction vector to normal vector, and then you can use that information to construct standard form. All right, the next set of problems are the famous ones. And it's worth starting a new video for them so they can all be together, like one very sad family.